Assalamualaikum. My name is Nur Asyilah and today I will explain for the question 1A and question 1B. Okay, so now let's start with the question 1A. Okay, the question asks to sketch the free body diagram of the object. Okay, so this is the figure that I already sketched, and this is where the ball. Okay, and then we have a weak force and the normal force that act on the ball. Okay, so that's all for the question A. Now let's move to the question B. Okay, the question B asks to calculate the speed of the object just before it leaves the surface at B. Okay, so for this question we can use the principle of work and energy. We have TA plus submission UA to B equals to TB. For TA we have half MVA squared plus summation UA to B we have MGH, and equals to TB we have half MVB squared, and then M we have M equals to 1 kilogram and VA equals to 0 meter per second, because the question above state that the ball is released from the rest, so VA equals to 0. Since VA equals to 0, this will be 0. Okay, and then we have MGH equals to half MVB squared. So since M equals M have the same value, so we can cancel out these two. And then what's left is GH equals to half VB squared. Okay, for GH we have G equals to 9.81, H equals to 2.5. This is because the speed of the object just before it leaves the surface at B. So this is the surface at B. So this is 3.5, and we have to minus with 1. So what's left is only this 2.5 meter. So H equals to 2.5. And then equals to half VB squared is the speed that we want to find. Okay, and then use the calculator to find the value for GH. So 9.81 times 2.5 equals to 24.525 equals to half VB squared, and then VB squared equals to 49.05, and VB equals to 7.0036 meter per second. Okay, so that's all for the question 1A and the question 1B. Okay, so let's move to the next person. Thank you.
Okay, Assalamualaikum. Now let's proceed to question 1C. For question 1C, we need to calculate the distance from the wall of the ramp at B to where the object strike the ground. Okay, firstly what we need to do is we have to list down the X component and the Y component. Okay, for the X component, there is X equal to X naught plus VBX T. This for X component. And then for Y component, let's write the equation first. For Y component, we use Y equal to Y naught plus V naught T minus 1 over 2 minus 1 over 2 GT squared. Okay, now let me solve for first equation for X component first. So we just put the value. X naught is 0, and then VBX is we take from question 1B, the value VB 7.00 360. Then we get 700,360 for x. So let me assume it as equation 1. Okay, now we proceed to y component. For y component, we know that y is -1, and then y not value 0 plus we know 0 minus 1/2. G is 9.81 t squared. We proceed to t square, and then we will get t square equal to 0.2039, and then we will get t 0 square root is square root 0.2039, and then we will get 0.4515. This is assuming as2. We assume it as 2. Then we can sub equation 2 into 1. So we will get the distance x is 0.036, t is 0.4515. Then we calculate it, we will get 3.1625 or 3.16 meter. So we get the distance of the wall, the distance from wall of the ramp at B where the object strike the ground. So the distance is 3.16 meter. Thank you. Okay, now let me solve for question 1D. The question 1D asks to compute the speed at which the object hits the ground. Okay, firstly what we need to do is by using the same equation at B, we also can determine the speed when the object hit the ground. Okay, we can take the equation from B. There is the kinetic energy, summation of T at A, TA plus the summation of internal energy from A to final when the ball hit the ground equal to the kinetic energy at final, we say as TF. So we know that the kinetic energy at A 1/2 mVA square plus mgh equal to 1/2 mv final square, v when the ball hit the ground. Okay, so we know the question, from the question we know the ball or the object is starting at the rest. That means the VA, the speed at the rest is 0. So we can conclude that at this equation is 0 plus m. We can slightly m, this m, so it become GH equal to mv final square. So we can rearrange the equation. It will be square root 2 GH. So we put the value to 9.81 gravity, and then the height 3.5. Then by using the calculator we will get 8.2867 or 8.29 ms. So that's how we get the speed when the object hit the ground.
For question 2a, calculate the velocity of the object just after it rebounds from the ground. Firstly, you must know about the C position. C position in here, v1y is 0 meter per second. After that, consider the vertical motion equation. The vertical motion equation is in here. You must substitute the value and you got the VCY1 is 4.429 meter per second. It's a downward. After we got the VC1Y value, apply the coefficient of restitution in the y direction to determine the velocity of the ball just after it rebound from the ground. The equation of coefficient of restitution is E equal to V ground 2 minus VCY2 over VC1Y minus V ground 1. Substitute the value and you got VCY2 is 3.1003 meter per second. That's the answer. For question 2b, compute the maximum height to which the object rises after the first bound. What we found is h value. After that, we must use a kinetic equation. Kinetic equation is the vertical motion of the ball after it rebounds from the ground. It's described by v to y. V to y in here, in h, in here. The VCY here plus 2a is a downward. The gravitational is downward. V S2y in we substitute as a h value minus VCY in here is 0. After that, V2y is automatic is 0 because it's in maximum height. After that, VCY we used question 2a plus 2 and gravitational is negative 9.81, h minus 0 because it's a C position. After that, we got the height 0.4899 meter. Thank you.